Okay, guys, we have here, no, not this one. I have this one right here, this one. Okay, you can see here the problem released on 2002. No calculator allowed. It's very standard with let me see what happened here. No, I can pin. No problem. So mhm. And this one, yeah. So the fundamental theorem of calculus is going to be correct. Okay.
Ese fui yo, Ramírez.
Aquí esta porquería. Okay,
Ese
well,
fui yo.
there it is. So here
That was
we
me.
have this one. So, oh, look. The graph of a differentiable function f is closed on the closed interval -13 to +15 is shown in the figure above. The graph of f has a horizontal tangent in x equals 6. It's obvious, right here is a horizontal tangent. And this is to make use of it. They define a new function g of x from the f using an integral. So is 5 plus 6 to x ft dt for the same interval 3 to 15. Then they are asking you to find three values of the new function. Obviously, you don't have an equation for this thing to do this integral, so you have to rely on the graph, okay? So everybody clear? So I'm going to write here precisely what I have. So it's g of x equals 5 plus the integral from 0 through x ft dt, okay? And then the first question requires that we find g of 0, g of, no, 6, g of 6, g prime of 6, and g double prime in 6. Okay? Okay, let me just stop sharing now. Here is the screen. You see that screen? Okay. G of x is 5, integral from 0 to x, ft dt. But this is 6, not 0. This is 6. Yeah. So the first thing we have to check is, okay, what is g of 6? G of 6 is the evaluation of this function in 6. So requires you put a 6 here, and also you put a 6 over there. So,
va a ser 0.
Correct. So this is 5 plus, yeah, the integral from 6 to 6. By definition is 0 because this is a line. And the lines have no area. So this integral is 0, correct? 0. So g of 6 is just 5, correct? Now, this is a point on the graph, okay? For 6, the y is 5. So the point 6,5 is on the graph of g, correct? This is just something extra. Okay, let's see now g prime of x. So now you have to find g prime of x. And g prime of x using our calculus, right, is the derivative respect x of, well, before that one, I need a parenthesis. Parenthesis is 5 plus the integral from 0 to x ft dt, correct? This one. So here is the derivative I have to calculate. Now, the derivative of the phi is 0, and the derivative of this is the fundamental theorem, the second form. The derivative and the integral cancels, so I have f of x. So g prime of x equals f of x. So g prime of 6 is the value of the function in 6. Now, well, I have to check here, right? Here, you see, what is the value of this function in 6?
3.
Correct. is a 3, correct? So I have to quitar esto, just to put that value on my problem. So I just stop sharing. This is 3. Okay. Question 1, question 2. Now question 3. G double prime of x here, G double prime of x is going to be the derivative respect x of G prime of x, correct? Or is going to be the derivative respect x of
x.
Correct? So this is the definition. G prime is equals f. So the second derivative is the derivative of this and the derivative of this. Now, this is f prime. Correct? The derivative. So this is geometrically a slope of tangents. Correct? Why is important I remember this is the slope of tangents? Because I have no function. I have only a graph. So here is the graph. And what is the slope of the tangent line in 6?
0.
Correct. That's very simple. Even is given right here. F has a horizontal tangent and x equals 6. So my answer is very simple. From the graph is 0, right? From graph. The same is from graph. Okay. So the first 3 questions, as you see, are not that difficult. Are just reading a graph. So no questions here. It's very simple, right?
No.
Okay, now we're going to be in a little bit more trouble because, well, the next questions are a little bit more difficult. So I have here, on what intervals is G decreasing? Justify your answer. Okay, so B, G of X decreasing on, so this is
También
what
es fácil.
G of X is decreasing on, yes sir?
También es fácil.
Yeah. What is the criteria we have to do? G of X is decreasing.
When the area is negative.
Is decreasing on A comma B is an interval if G prime of X is negative on the interval. Not the area, the tangent line. Remember, if this is the graph, correct? Here the function is decreasing because the slope is horizontal negative. Here the same. Here is decreasing, the slope is negative. So you go down, correct? Here is increasing, so the slope is positive, correct? So that's the criteria we have to apply. So who's G prime? G prime of X equals f of X. So this has to be positive. If G prime, in this case negative. If G prime has to be negative, then f of X has to be negative. Oh, okay, I have to check the graph. So where the graph of f is negative? Nowhere, somewhere. Nope.
Es que se está cortando, Ramírez.
From 0 to 0 and total 15.
Okay. So where this function is negative as well, from the graph, G prime of X negative on negative 3, 0. And where else? 12, 15, correct? So this is what we have to write in our paper. G, where G is decreasing, G of X is decreasing on AB if G prime negative on AB. G prime is f of X, and this has to be negative. So from the graph, G prime is negative on these intervals. That's it. You don't have to think too much. You just read the graph. Okay. No question? Very easy, right? Okay, next one. On what intervals is the graph of G concave down? Justify your answer. Okay. Now, so I have to write here concave down. So the function has to be like this, correct? That's concave down. So it's where you have a max. Concavity down implies, in this case, that you may possibly have a max or something like this, correct? Okay, what is the criteria we have to look? So G of X is concave down. On AB, if what happened? G double prime of X is negative on AB, correct? So this is the criteria we have to look at. G of X is concave down in an interval if the second derivative is negative on that interval, right? Okay. Let's check the graph right here. Okay, who's G of X? Who's G double prime?
That's the slope of the graph
Correct.
X.
It's F
So
prime.
it's from 6 to 15.
So what I have is this one, right? G double prime is F prime. So again, so this negative, so negative tangents. Where I have negative tangents. Okay,
6
let me
to
see
15.
the graph again. Right here. So the negative tangents are going to be from this point, all these tangents are negative, correct? From 6, correct, to 15. On this side, all the tangents are positive, correct? So from graph, from 0 through 15. So there is. So this is my answer. This is my reasoning. Remember, if you want all the points, you have to state your reasoning because they want to justify your answer. J is concave down on this. This is your concept. Then this is the application of the problem. G double prime is F prime of X. This has to be negative. Negative tangents from the graph 0 to 15. Correct? No, 6 to 15. 6 to 15. Yeah, I don't know why I put a 0. That's 6 to 15. Right? Okay, not a big deal. Where is the secret of this answer? This concept. You have to remember those concepts. Remember, where are they? You don't have to look too much. Formula booklet, this one. Right here. Calculus APBC, here is the concavities, page 15. Everything is right here. Okay? Everything is right here. Okie dokie. Well, last question. Let me see right here. Share screen. This one. Okay. This said, find a trapezoidal approximation for -3, 15 for the integral from -3 to 15 of FTDT using 6 subinterval of length 3. This is okay. 6 subintervals of length 3. Okay, we have not covered yet the trapezoidal. No, but this is going to be easy. Everybody knows what is a trapezoidal, correct? Yeah, okay. Now I'm going to try to do over this one. No, this one, no. escape. Not this one, tab, no. A ver aquí, negro, no, vamos a usar esta, right? Okay, no, no initials, no. No, tampoco. Where is it? No, let me just use this one much better, annotate. So this is -3 to 3. What length is this? 3. From 0 to 3, the length is 3. From 3 to 6, the length is 3. From 6 to 9, from 9 to 12, and 12 to 15. So my subintervals are going to be these ones right here, these ones right here, right here, right here, right here, and right here. Okay? So I split this interval, all this interval right here, in 6 parts. 1, 2, 3, 4, 5, 6. That is exactly what they want here, right? Now, we have been using rectangles, correct? So we use, for instance, this rectangle right here. Then we use, for instance, this rectangle right here, right? You remember how to use rectangles, correct? So this is the trapezoid, this is the Riemann sums. But the trapezoid, let me just clear everything here, clear all drawings, correct? Requires to use trapezoids. Well, what is a trapezoid? Two parallel sides, two no parallel sides. So this is going to be the point. I'm going to draw a line from here to here. Well, suppose that's a straight line, right? And my trapezoid is going to be this one, correct? Well, this is pretty much a triangle, right? Then I'm going to draw another trapezoid. Let's just put from here. Let me see. Clear everything, all drawings. Let me see. Si lo hace así. I haven't used this one yet. Okay, let me see. Click and click. No, it's not intelligent. Let me just draw a line. ¿Qué es esto? No. Okay. Erase both that está. Mouse select test. No, I don't see really too much. Well, I'm going to try to do the best drawing possible. Let me just try here. So from here to here, and we have to try this triangle, correct? Then we draw this triangle right here. It's because I'm using the mouse. The mouse, you know, is kind of picky. And then the next trapezoid is from this point. No, not here. Eraser right here. Now another point. Ok, vamos a usar esta, right? Format, tampoco. Annotate otra vez. Yeah. From here to here, you see? And then the trapezoid is going to be this one right here. You have this, we're going to do this. So you can see the trapezoids I'm drawing pretty much.
Oh, okay.
Draw from here to here, and then this one, hasta abajo, right? So you take this trapezoid. Okay? So this is the idea. Then we draw this triangle right here, and then this triangle right here. Okay? Sorry about this one, but I don't have a pen to do this. Yeah. So this is what I have. So what we have to write in our, yeah, in our paper is going to be the integral from 0. Let me just say here. Stop annotate. Let me see this one. Okay. Just move this one here. Okay. Okay, there it is. Let me just move this a little bit down. So is the integral from -3 to 15. So the integral from -3 to 15 of f dt is going to be the trapezoids, this one. Let me just go back here a little bit more. Let me just try to do this to the right. I don't know what I lost, but I lost the shapes. So let me just erase this part. Annotate, erase everything, clear all the drawings. So let's work on this one. So let's work this trapezoid. Is 3 by 1 divided by 2, correct? That's a triangle. So is ¿qué sería? A ver, a ver, before that one, let me just stop sharing. This is trapezoids with trapezoids. Hmm? What is the formula to get the area of a trapezoid? Area of a trapezoid. So as well is the addition of the two b's at parallel bases divided by 2 times the height. In this case, yeah, the height, you see this one, let me just draw something like this. This is, you have x and y, this is x and this is y, correct? A trapezoid, for instance, this and this, because this is a trapezoid, this is the height, this is base 1 and this is base 2, correct? This is the height, base 1 and base 2, so these three things. So it's very simple. H is xn minus xn minus 1. So if this is xn, this is xn minus 1. So you have this difference, this is the height. And then b, so is going to be f of xn minus 1. And the b is f of xn, correct? So is what we see, because if this is a function, correct? So this is xn, f of xn, correct? And so on here. So is what we are going to do here to approach this integral, right? So this is going to be equals, and then we are going to have the first interval. The first interval, let me just go back to the graph, is right here, is from 0 minus 3, minus negative 3. So I'm going to have parentheses, 0 minus negative 3, and I'm going to have, stop sharing, I'm going to have f of negative 3 plus f of 0, correct? This is the first trapezoid. Let me just do this a little bit better. So equal, parentheses, f of negative 3 plus f of 0 times 0 minus negative 3. That's the first trapezoid. What is the second trapezoid? Well, the second trapezoid is going to be from 0 to 3, this portion right here, right? This portion and this height. Okay, so stop share. So we're going to do is okay, plus I'm going to have f of 3 or f of 0 plus f of 3 times 3 minus 0. That's the length of the interval. What is the next trapezoid? Well, the next trapezoid, following the same, right, is going to be, so delete and delete. So it's going to be this base, then it's going to be this height, and then this height. So this is going to be the trapezoid, correct? Like right here. You see that trapezoid, pretty much? So it's going to be the f in 3 plus the f in 6 times 6 minus 3, correct? Yep. So that's the formula, right? Plus, and then I continue now. You see the pattern, how it's going?
Yeah.
So what is the next point?
F of 6 plus
away.
f of 9.
F of 6 plus f of 9 times 9 minus 6,
9 minus 6.
Plus f of 12 plus f of 9, no, f of 9, f of 12 times 12 minus 9. And the last one is going to be f of 12 plus f of 15 times 15 minus 12. Those are the 6 trapezoids we have to consider, correct? Now, let's see, what is, I have to go and in the graph, if you see the graph, f of negative 3 is negative 1, correct? So I'm going to put here -1 plus 0, right, times 3, correct? Because 0 minus 3 minus -3 is 3. The next one is going to be f of 0 is 0 plus f of 3 is 1 times 3 plus the next, in the next graph you're going to see that is 1 plus 6 is 3 times 3 plus 3 plus 1 times 3 plus this is 1 plus 0 times 3, and the last one is sería 0 plus -1, right, times 3. Okay, everybody see those numbers? So all these are threes, all these threes right here. And these are the values you get from the graph. They are right here. Then we solve the thing. Let me just put it right here. So this is -3 plus 3 plus 12
12
plus 12 plus 3 minus 3. Correct? So we cancel these threes, right? And my area is 24. Okay? So trapezoids is something you learn since what? 8th grade?
Yeah.
Pretty much. So the only you have to do is see the trapezoids in the graph. Let me just put the graph again back. This one, right? You have to see the trapeze as well. With a better drawing, this is more evident, correct? But the trapezoids run from here. Well, it's worse. Delete. So it is from here to here, more or less. You see a trapezoid, right? And then you draw all the trapezoids. This parallels the value of the function at the ends of the subinterval are the bases. The difference between this end and this end is the height. So it's base plus base divided by 2 times height is the formula I use. And then we approach. Now, why I did this long? Because in this case, all the intervals are the same. But if the intervals are different, this formula works also, correct? So you do trapezoids on paper. Yep. Any question?
No.
Nope.
Any question, complaint? Luis, everything fine?
Yeah, everything fine.
Okay. Well, let me just now check the next problem we can do. So I'm going to take this, delete, this, delete, this, delete, this, delete. And then let me just take this one, and we solved this yesterday. So let's see this one, another fundamental theorem problem. So this problem was released in 2003, no calculator again. Remember, what is the way I'm going to proceed? I'm going to do first the first ones, and then for tomorrow on Friday, I'm going to go backwards. So I'm going to take the last release backward, correct? So the first ones usually are simpler. That's why I begin with them. And the last ones usually are the complex. So that's why I finish with them. Okay, okay. Bueno. Same. Let f be a function defined on the closed interval 0, 7. So you see here from 0 to 7, right? From here to here, right? And of course, you have line segments, correct? So technically you can have this equation analytically, so you find these lines and you define on the proper intervals, but that's not going to be the point. We're going to use the graph directly. It's easier. And again, you define a new function here. You see, this function is the integral from 2 to x of f t dt. That's a new function. Again, you have to find the values for this new function at 3, g prime of 3, and g double prime of 3. Correct? Okay, now you have the experience of the previous problem, so I want you to get those by your own. G of 3, g prime of 3, and g double prime of 3. Here is the point 3, okay? So if I mark this one, here is 3, right here. So right here. You get it? We're still working.
I got the first two, pero el último está raro.
Okay, vamos a ver. Let's stop right here. This is what you have. This is the way the function is defined, the integral from 2 to x of f t dt, correct? Then you have to find g of 3, g prime of 3, and g of 3, correct? Now, g of 3 is this integral of this function evaluated in 3. So you put a 3 here and 3 here. So you have the integral to 2 to 3 f t dt. Now,
That's
this
3.
is the area between 2 and 3. So if you check right here, so the area between 2 and 3 is base times height, or is this triangle, so it's 2, and this is 1 times 2 divided by 2. This is a 1, correct? So this is 3, correct? This area is 3. That's what you put here. So 3. The next one is g prime of x is the derivative of this, so it's f of x. G prime of x is equals f of x. So you have to do g of prime of 3 is f of 3. So I check the graph, correct?
Here's 2.
And the graph is a 2, correct? So, okay.
Yes.
So this equals 2. Now the last one is g double prime is f prime of x, because this one, right? G prime of x is f of x, so this derivative is the derivative of this one, so it's right here. So I have to find f prime of 3. So this is the slope of tangent. Okay, let's go to the graph. What is the slope of this tangent?
48.
Square root of 7.
Okay, so it's rise over run.
E to the power of 45.
1, 2, 3, 4 divided by 2.
¿Cómo fue?
A ver otra vez. This one. So you want the slope of this tangent line. The tangent line is the same line in this case. So it's a negative. So it's rise over run, 4 over 2. So my slope is negative 2, correct? Okay, no problem. This is easy. Okay. Okay, you're back. What happened?
You're back. Usted
I don't know. Something happened. Something strange happened. Okay. Let's see this one. Okay, we're the same 3. Okay. Any questions right here in this portion? It's easy, right? Okay, let me just take this one now, erase, delete, and answer the next question, right? B. Find the average rate of change of G on the interval 0 and 3. Okay, the average rate of change. So the average rate of change is the slope of the line joining these 2 points. Let me just do something here on the board, right? So we have this one. So if you have a function, this function, and you want the rate of change between A and B, correct? So right here, so this is the point B, f of B, and this is the point A, f of A, correct? So the average rate of change is the slope. So it's f of B minus f of A over B minus A. So this is the average rate of change, correct? The slope of this line. Now I'm going to move to my screen here. So it's right here and right here between 0 and 3. So I need the slope between these 2 lines. Okay, let me just see. So what slope is this one? This as well is going to be the average rate of change is delta f over delta x equals f of b minus f of a. I'm going to write this one here, b minus a. So this is going to be f of 3 minus f of 0 over 3 minus 0. Okay. Now, how much is f of 3? If you see this one, f of 3 is 2. F of 0 is 0 over 3 minus 0. So this is 2/3. So this is what you have to put on your paper, this one. The average rate of change is the slope, delta f over delta x, right? This is f of b minus f of a or b minus a. Then you have b is 3, a is 0. So f of 3 minus f of 0, right? Over 3 minus 0. And then you have 2 minus 0 over 3 minus 0, 2/3. This is my average rate of change. The only you have to do is remember what is the average rate of change, the slope between the points. Okay, this one right here. Right here. So, not a big deal here. Okay, let's see the last portion of this problem, right? Okay, right here, this one, delete. So I need to do this one right here. For how many values of C? Where C is between 0 and 3, is G prime equals to the average rate found in part B? Explain. So this is the situation you have here to explain why or why not you have a tangent that is parallel to this line. So let me just draw the line again, right? Or pretty much pretend to draw the line. So do you have a tangent line parallel to that one right here in these 2 lines? Do you have one?
No.
No, you don't have one. So the answer is for no value between 0 and 3, you have this is a derivative of G prime, guys. Is G prime, perdón, no, is G prime. Who's G prime? Who's G prime?
F of x.
F of x. So really is 2/3. Let me just then erase this one because I was thinking the derivative. No, let me just take this one, delete, this one, delete. So we know that it's 2/3, so 2/3 is pretty much like right here. Correct? So it's between 0 and 3. So for how many values G prime is equal to 2/3? Is right here, correct? For this value, right here. So I don't know, can you calculate pretty much that one? For how many values? Well, they don't ask you what value, for how many.
How many?
So it's just one, exactly where the cross happens, correct? So you can explain this, explain your reasoning. This is okay. G prime of X. So let me just put this one. If G prime of X equals, let me just stop sharing here. So if G prime of X equals F of X and you want G prime of X equals 2/3, then F of X equals 2/3. From graph, F of X intersects Y equals 2/3 once, correct? Only once, correct? So everybody's clear. The reasoning is what you have to explain because this is written. So if G prime is F of X, G prime of X is F of X, and G prime has to be 2/3, that is the condition of the problem, then F of X has to be 2/3. So this is a Y, this is a Y also. So the two Y's have to be the same. So from the graph, F of X intersects Y equals 2/3 only once. And that's it. You make your reference and you solve your problem. Okay, last question, correct? And we finish today. So this one, right? And we have this one. Find the X coordinate of each point of inflection of the graph of G on the interval 0, 7. Justify your answer. Okay. Points of inflection. How do you define the point of inflection? Let me just write it here. Don't remember? You don't remember? This is the definition you have to remember. Remember, this is here. The concept is right here in the formula booklet. So this is the point. F of X has an inflection point at X equals 0 if, what happened? The second derivative in X0 is 0 or is undefined. This is a horizontal tangent for F prime. Yeah. Horizontal tangent for F prime of X. So this is the second derivative. This is the slope of the tangent lines of this derivative, correct? So let's go back to our screen. Okay, now, do you have horizontal tangents?
No.
No, you don't have horizontal tangents. So F prime is not 0. But you have points where the derivative is undefined. Where are the points?
2 and 5.
In 2, correct, right here, -5. What about here? So in this one, the slope from the left is different from the slope from the right. So this is a peak, you have many tangents. Here you have many tangents, here you have many tangents. So technically, how many inflection points you have?
Right?
How many?
3.
Following the definition, this F prime is undefined. So undefined means you have a peak. So I have 3 peaks. If I check this one, I have 1 peak, 2 peaks, 3 peaks. So it's undefined here, here, and here. So I have 1, 2, 3, right? Inflection points, correct? So how do you explain that? This is so this is what you're looking for. F of x 0 or undefined. It's a front graph. Yeah. Let me see. Oh, is it really this one? G double prime of x is 0. From the graph, G double prime of x equals F prime of x. Yes. F prime of x is undefined at x equals 2, x equals 4, and x equals 5. Because f of x has peaks on these values, at these values. Then there are g of x has 3 IPs at x equals 2, x equals 4, and x equals 5. Correct? This is pretty much that you should write explaining to the readers your reasoning, why you conclude what you have. And again, everything relies on this concept. G prime, the inflection point is where the G double prime is 0 or undefined. Then from the graph, G prime of x is F prime of x. F prime is undefined in these 3 points because it has peaks at these values. Then G of x has 3 IPs at 2, 4, and 5. Okay. Questions here? Bueno, if you have time this afternoon, try to go to the next problems, correct? Yeah. So it's very important you practice by your own. For instance, you have here, you see, same as before, you have to find g of 0, g prime of 0. You have defined a function as an integral, right? Find all the values with relative maximum, absolute minimum, okay, and inflection point. So you see the concepts are pretty much the same. You have to apply these concepts again in all these programs, okay? Well,